Bueno, hello guys, thanks for joining. Just to check, everybody here speaks English, right? Or understand? Yeah. Okay, my name is Nico. I'm from Buenos Aires. I'm ambassador for Uniswap Foundation. I've been working on smart contracts for a couple of years. Now I'm working on a product also building on top of Uni before hooks. So yeah, that's why I get engaged and learn a lot about the ecosystem. First of all, these tracks are presented by Uniswap Foundation. Uniswap Foundation is an organization made to support the Uniswap ecosystem in terms of governance, decentralization, developer, and everything that you already know. So, yes, to jump in, I guess that you already know something about Uniswap. Since V1 is a permissionless protocol made for swapping one token for another. It changed a lot over the years. V1, we used to have like only ETH2 ERC20s. Then V2 introduced all kind of ERC20s. And V3 introduced concentrated liquidity. This is like another form of managing liquidity and make it like much more efficient. And the interesting thing that we will be covering today is V4, this new version that has been live for a couple of months this year. Some differences that you will find when trying to build on top of it. So first is a singleton architecture. This means that all the contracts are, everything happens within a single contract. In previous versions, we have like one contract per pair or per pool. In this case, like everything happens inside one contract. There's an unlimited fee tier set, so you can choose whatever fee tier that you want. You are not limited to the 3 or 4 options that you had before. You can choose whatever you want. This is really powerful. Like a couple of months ago, the more part of volume for stable pairs were already on V4 pools because they could choose like a lower fee tier, so that's already really powerful. There's dynamic fees. You can also change the fees from the hooks, so that's something interesting as well. All tokens are managed internally in some standard that you will see there. So you don't depend on making a lot of transfers for swapping and routing, but you deposit tokens, you make like a lot of swaps internally, and you can then withdraw them. That is like so much gas efficient. There's flash accounting. This means that you can do a lot of trades, and at the end of the trade, you will check the deltas, the balances, and check that everything is fine. So you can also do some kind of similar to flash loans or interesting stuff when routing inside a pool manager. And there's hooks. That is the most important and fun thing that we will be covering today. So just to give you an idea, here we have like a V3 or V2 architecture where we have different contracts for making one single trade. In this case, there's like 10 external calls. For those coding Solidity, you know that making external calls is the most expensive thing we can do from our contract. So for routing a trade throughout 4 pools, in the middle there's like 10 calls to ERC20s and the pairs from the router, so that's a lot of gas. And when seeing before, you can see that everything happens within one pool. So you, in this case, you will deposit some ETH, get the ERC C909s, that is kind of this voucher, this wrap token that lets you do the trades. You route and do all the trades internally, and you withdraw what you want to withdraw at the end of the trade. So this is like so much gas efficient. In this case, we can see that a similar trade on V3 and on V4 with the same almost gas price is like 10x less gas for our transactions. So yeah, it is like really efficient. So what can we do with hooks? At a high level, hooks let you put your own code within one pool. So you can use one of these 10 hooks, and you add your code before and after some point in the life cycle of the pool. So you can put your own code before or after you initialize the pool. You can put some code when somebody adds or removes liquidity. You can do it, maybe the most common, when you are swapping before and after. And donate, there is kind of a tip for LPs. So this enables you to do a lot of things. You can like revert trades. You can have like a whitelist and check who is trying to add liquidity or swap and revert the transactions if they're not in the allow list. You can modify data. So for example, in the swap, you get the default calculation of Uniswap for the trade. You can modify that or override your own curve and your own trading logic. So how this works? So first, there's like a couple of different options. You can have like just one hook contract that you are using for one pool. You can also code in a different architecture your hook contract so that it works for multiple pools. But you cannot have more than one hook contract for your pool. This means that when you are creating a position in a new pool that doesn't exist, like before, we would identify the address or which is the pool by the token A, token B, and the fee tier. Now we are adding another thing that is the hook. Like you can have all those possibilities with infinite hook addresses or none. So if you don't use hooks and you create a position, it's like B3 but much more efficient because of these gas things that are new. But you can add a hook and customize a lot of these things. Yeah, so when we are routing the trade, the pool manager, that is the single contract that handles everything, will check if the hook address, if the pool that you are trying to trade has a hook, then it will check the hook address. It will know which of the hook they have implemented. So in this case, we will check the before flag. If it's true, it will call the hook contract to run that logic. It will return with a callback to the pool manager, execute the swap, and the same if the after. Obviously, you can choose which ones to implement. In, for example, swapping, you can implement like only after, only before, or both, depending on what's useful for you. What else? Like two main resources for building. So you have the before template, that is a repo that gives you some templates and base to build on top of. And the other tool that is really powerful is the OpenZeppelin Uniswap hook library. So just as we have like the contracts with tokens and upgradability and everything that we already use from OpenZeppelin, there's a dedicated Uniswap hooks library, which has a lot of like basic stuff to build on top of, and also like some really useful templates that just by coding and adding a couple of lines lets you do like really powerful stuff, and we will be looking at it too. So I'm gonna skip this and we're gonna go back here. Just a couple of examples to understand better what we can do. For example, if we are working on stables, we could create a hook to incentivize peg stability. So in this case, we will have like a fixed one value, or maybe we're querying an oracle to see which is the actual value of the stablecoin. And we can like make different decisions regarding which is the direction of the hook, or which is the current price and the target price. So for example, if like the price now is 1.02 and we want to incentivize the stability, we can modify a couple of things to incentivize it going closer to 1, and making some other things to then incentivize going it like the paying more. In this case, for example, we could change two things. One is the fees. So with hooks, we can modify the fee that is charged to users, that meaning the fees that go to LP, to the liquidity providers. So if they are going closer to 1, we can lower the fees, so we incentivize those trades, and we can change also the deltas. What are the deltas? Basically, amount you put in, the amount that you will have to take out, or the other way around. So you can also modify that. So basically, how much the user is putting in, you can choose how much they will take out. In this case, you can use like default Uniswap math that is built in on the protocol. You can get the default amount and modify it. So let's say that you calculate the basic delta that is already brought by the Uniswap protocol, and you like make it kind of a discount or adding more to that, so you can build on top of it. Or you can override it and do your own math curve. Like in this case, the possibilities are endless, and you can do a lot of interesting stuff. You could also make like a B2 like trading logic between your before pool. Similar to this, let's say that you are working on meme coins and you want only them to go up. You can create like this dual pricing thing, where you get like you detect which in which direction the trade is going. So 0 for 1 or 1 for 0 is like the direction of the trade. If it's going up, you can give a better delta or lower fees. If it's going down, you can give like worse deltas and higher fees. So you can play with these things to make interesting stuff. Another great example is MEV taxes. Like you can use priority fee to hear like how much the user is paying for the transaction above the base fee. If you identify the priority fee is very high, that high likely is a MEV attack or a strategy. You can identify MEV and increase the fees. So there's like a revenue sharing between searchers and MEV and LPs. Like previously, a lot of value were going to searchers and none to LPs. In this case, you can like share the extracted value with LPs. Another really powerful thing, rehypothecation. This means that you can deposit the funds that are deposited for liquidity can be used to be deposited in other stuff. So after the swap, you will deposit all the liquidity in Aave, Morpho, or any other protocol. Before executing the swap, you're withdrawing, getting the assets, executing the swap, and depositing back. This means that LPs will not only gain LP fees, like the default unit thing, but they will also earn from yield from other protocols where it is deposited. So this is also like a really cool thing. And with the OpenStable library, there's the rehypothecation hook. I think that I don't know if it's like on the last release, but you can find it on the repo. So just overriding these 3 internal functions, you can get rehypothecation. So it's like just deposit to this protocol, withdraw it, and some amounts calculation, and it's like a really straightforward implementation, and it's like really powerful. Resources, there's the hacker toolkit for the hackathon. You can ask for the QRs later because we are kind of rushing with the time. We will be here on the booth and on Telegram, so you can reach out to us. Angela is also here, and there's like a Telegram group for support, so happy to chat about that after. And if I think I have 3 minutes left, I'm going to show you quickly. Okay, so key repos. B4 Core is the implementation of the Uni protocol. Here we'll find the hooks interface. So this is basically what the pool manager will be querying to our contract that is like these functions that we're discussing. Important thing, you will see that some of these functions give us some information from the hook scope, like who is the sender, the pool key, that is the identification, swap params, hook data, that is something custom that we can build in to receive information from our router. Then there's base hook, that is like the hook that the contract that we are always inheriting because it has some nice features. Let me find it here. Okay, so basically we will inherit this base hook that basically what it does is it implements the hook functions with the reverse, so we have to inherit and re-implement them if we want to use those hooks. And we will be having, for example, in this case, if we want to do some compliance whitelist thing, we assume that we have some other contract with the whitelist. We save the whitelist on the contract, and when executing a swap, like before add liquidity, we check if the sender is in the whitelist. If he isn't, we will revert the transaction. Otherwise, it will continue. So this is like just one line and compliance whitelist built on our hooks. We can check an NFT collection, and if the sender has some amounts, we can set the fee, like 0 fee or more fees. We can do some fun thing that if the block number is even, we can charge fees, otherwise not, just as an example to understand a little bit more. So yeah, there's like a lot of things that we can do with this. It's like playing with the incentives for different stuff. And going back, just to wrap up, there are 2 different tracks. One based on stable assets, so we're working on stable coins or things like that, so we can create the best incentives for for that kind of assets. And then we have another track for volatile pairs. This means that for other kind of assets. So there's like a lot of things that we can do for managing liquidity, getting the best incentives between traders and LPs. That's an interesting because there's a lot of hooks that gives a lot of benefits to traders, and there's a lot of hooks that give benefits to LPs. I think that the most interesting thing is like getting incentives together for both of them and making it like the best. That brings also like LP profitability and volume. But yeah, there's like endless possibilities to build with this. Am I forgetting anything important? Yeah. Yeah, actually, yeah, I thought that I quite rushed. I thought we had less time. Uh, yes, I thought I was 55, but it's 45. Yeah, let me show you. So the other repo is Uniswap hooks. This is the library, and there's like these base things that we can inherit and implement if you want to do like our own math curve, if we want to manage liquidity internally from the hook. The async swaps is the thing that enables us to override math curve and return like our own deltas, not based on Uniswap math. There's some things for fees, like have a dynamic fee, set it based on different stuff. So another interesting example is you could have kind of a volume oracle. You are saving internally on the hook how much it was traded. If you see that the volume is down, you can lower the fees to incentivize trading. If you see that there's a lot of volume, you can increase the fees to get like more profitability to LPs. So that's interesting things. So before you had to build oracles on your own, like outside the contract and querying all the time to get the info. Using hooks, you can enforce like an internal oracle that you know that will receive information and save it in every single trade. So that's interesting, and you can build things with that. Like for example, this volume thing I think is quite interesting. And if I can see here, okay, I don't know the status of the last release of OpenZeppelin, but if you go here to this release, that is the last one, I don't know if it's official yet, but it has like some new hooks that are really fun and interesting. So for example, you have already built-in implementation of order books, the liquidity penalty, rehypothecation, like these things that were really hard to build. Like all the internal logic is already built for you, and you only have to put some things together in order to use them. For example, the rehypothecation, like managing shares and everything is like really difficult and also risky. In this case, you can inherit OpenZeppelin implementation and just implement where and how to deposit, to withdraw, and how much is already deposited. And in that way, it's already done. There's some other things like anti-sandwich. It's an interesting workaround for avoiding sandwich attacks for users. Then there was another one, I think that is the equality penalty to avoid just-in-time liquidity attacks. So something that happened is that when a searcher detects that there's some large trade coming in, usually there's some searcher that puts a lot of liquidity in that tick to get like the most of the fees. In this case, you can create like a penalty system, and like they are not incentivized to do that. So yeah, there's like a lot of interesting and fun things that are already implemented, and we just have to code a couple of things, and we already have like a really interesting and powerful hook. Yeah, I think that is mostly that. Maybe. Okay. Yeah, what Angela is saying, that we're looking like for the best hook implementation to see that it's like something interesting and powerful. You can rather like create your own from scratch, use fake hook and code it yourself, or you can leverage also Uniswap library from OpenZeppelin and create like a lot of stuff, and maybe you can like do it much faster and get to more production ready and testing and everything. Okay. And just for testing, there's also a lot of tools and things to do. Like, well, I can share this later because it takes some time. But it's like really, really easy to test. You can like deploy all the stuff and get it together like in a couple of lines, and you start testing, and it's like much more. It's much easier than you would expect. Um, yeah, I think that we're close to ready. Any question here? Yes, we're gonna share again the Telegram QR code here. Yes. Any questions? Yeah. There's no mic, I think. Yeah, so in that case, you will create your hook contract and then initialize a pool with token A, token B, the fee tier of its dynamic, and the hook address. But the liquidity will be managed only for that pool for those tokens. So yeah, you will have to bring and attract liquidity to your own pool implementing that hook, if that's a question. Or yeah, like I think that in mainnet and production, there's like a lot of things about incentives and to really prove that the profitability for LPs is higher. Like if you just implement hypothecation, there's a lot of incentives for liquidity providers to earn LP fees plus AVE or lending or whatever yield from other sources. So I guess that it's like creating incentives for traders to get volume, LPs to get more profitability. But yes, you will be competing with all the other like vanilla pools with no hooks. Yeah, yeah. I know if it's like a certain threshold, but yes, I think it will take some time, but it's worth trying. Another question? Okay. Well, we'll be around and at the booth, so happy to chat and whatever. Thank you. There's some swag here.